So we're working on the introduction to geometry assignment. In this video, I'll do some examples and give you guys some chances to maybe work on your own and see if you get the right answer. So let's start with this first one. We're working with the line segment addition postulate in this case. So I'll pull up that from my PowerPoint so you guys can take a look at it. The line segment addition postulate is right here. Okay, this is that if A, B, and C are collinear points, and B is between A and C, then AB plus BC is equal to AC. So if I was to tell you that this was 3, and that BC was 7, okay, all that this is telling us is that if these points are collinear, which means on the same line. Okay, that's all that means. So A, B, and C are on the same line right here. We can see that clearly. Okay, so AB we can see is 3. Okay, and then BC is 7. Okay, what this postulate is telling us, okay, it's basically a definition of distance, right? To add up the distance of the whole line, right, I would have to add up the two pieces, which are 3 and 7, and 3 plus 7 is 10. So that would be the length of the whole line segment. So this is all the line segment addition postulate is. It basically tells us that we can add up the two pieces of one line to make the whole line. So by doing this first example that we have on our assignment, we can see that we're in the same situation. We have 3 points on a straight line. Okay, so the idea is it doesn't really have to do only with A, B, and C, right? We don't only care if it's A, B, and C on the line, right? The most important thing is that we understand that they're on a straight line and that B is between the other two, okay? And this has to be true. So what would be true in this case, right? Because now I have different points. I have L and then M and then N, right? So the line segment addition postulate says that if I add up the two pieces of a line, I'll get the whole line. So what we would write is that LM, okay, and LM is this part of the line right here in between L and M, okay, and then we have MN is this distance from M to N, right? So if I add up the two pieces of the line, I should get the whole line, and the whole line is LN. So notice this is the same postulate that we're using. It has nothing to do with the letters and more to do with the way that they're situated with each other. So now what we should do is change this question mark into an X. And then what we create is a one-step equation, because now we can substitute everything in, right? LM is equal to X. That's what we want to find, okay? MN is 5. So we'll write X plus 5. And now for LN, which is the whole line, this is our LN, 16, right? It's telling us the whole distance from here on L all the way over to here on N is 16. So at this step, what we have to do is subtract 5 from both sides of the equation. And when I do that, I get X equals 11. And this is the way that we would do these problems. Now, I always tell you guys when we're doing these problems, it's read, label, think are the steps. So after you get your problem done, okay, we should always go check, right? So after we read, label, think, we want to go check our work. So let's go see what happens if I put 11 in here for X, okay? Does this make sense? Does it make sense that 11 plus 5 is equal to 16? That makes perfect sense, right? So we know that we did something reasonable, okay? So you could work on number 2 now. Maybe you could pause the video and try it on your own. And hopefully you got an answer on your own right now, so let's go try this one. So in this case, what's going to happen is we'll change the question mark into an X. And as I said before, we'll write our line segment addition postulate. This is that RS plus ST equals RT. Okay, because of that, we can now substitute all of our letters in. Okay, RS is right here, that's 8. Okay, but ST is X, because from here to here we had the question mark. So we'll leave that as an X. So now we have to put the value for RT, and RT is equal to 12. So to solve this one-step equation, I need to subtract 8 from both sides so that we can get the X by itself. So keep our equal signs lined up, right? I guess I could do this in red. And our equal signs are all lined up. And we can see that on the left-hand side, the two 8's canceled out, right? Those go away. And so the only thing we have left on the left side of the equation is x. But on the right side, we'll have to do 12 minus 8, and 12 minus 8 is 4. So our final answer for this problem would be x equals 4. Again, we can go label the picture and see if that makes sense. Does that make sense that 8 plus 4 is equal to 12? That makes perfect sense. So that means that we're doing this correctly. Okay? So the problems won't always work that way. There will be different things that you have to find. So again, always think. Don't just add or subtract. Okay? Always think when you're doing these problems. So this would be a good one for you to try on your own. So again, the line segment addition postulate that you should have wrote would have been that EF plus FG equals EG. Again, the idea that you want to take from this is that the two pieces of the line, the two pieces, right, EF and EG, make the whole line. So EF is 12, and for FG, we're going to change the question mark into an X like we do every time. So put an X here, and we have this equal to EG, or sorry, in this case, EG is equal to 24. That's the whole distance. So again, this is a one-step problem, and I want to get rid of this positive 12 that's over here. So to get rid of the positive 12, we'll subtract 12 from the left-hand side of the equation and subtract 12 from the right-hand side of the equation. This leaves us with x equal to 12. So again, we go label the picture and think about it and make sure this makes sense. Yeah, 12 plus 12 is 24, so we're thinking correctly. So to practice these, it kind of takes that you make a little mistake here and there so that you can kind of learn what not to do. So number 4 would be a good example for you guys to try right now on your own, and I'll drop the answer up here. Okay, so please pause this and make sure you can figure it out on your own, especially the line segment addition postulate is the part that I would want you to have. Okay, so for this problem, we would want you to write JK plus KL equals JL. Okay? And then after that, we can go put everything where it goes, right? JK is equal to X. So I'll put an X there. Then for KL, that's 8. And then JL is equal to 14. So in this case, I'm going to subtract 8 from both sides of this thing. And I'm going to get that X equals 6. All right. So that's what I'm working with right now. The next problem is to actually use an equation. So it's going to be slightly more complicated, so follow along because these problems are going to be the ones that I got most of my questions about. Okay, we had a common assessment with all the other Math 1 classes, and we had problems like this, and some of you guys kind of showed that you didn't really meet the standard for this one, so this would be a great place to start so you can figure out how to raise the grade on that exam. First thing is that we want to write ML plus LK equals MK, okay, the line segment addition postulate. Now, if I just take these two pieces, right, ML is 2, and LK is 8x. So I'll write those in the places where they go. Okay, but MK is the whole line, and MK is equal to this whole thing of 1 plus 9x. So that's going to go on the side on the right. Okay, so here we have to understand how to solve an equation now. This is not a one-step equation like the last one. Now we have a two-step equation. So to solve this one, what we could do is subtract the 8x from both sides. Okay, I usually recommend you guys when you're doing algebra, okay, it's always okay to do some operation to both sides of the equation. But what we want to do in this case is probably end up with a number that's not negative. So if I subtract 8x from both sides, what that does is it turns the left side into just 2, because we would say that these two things eliminated, right? They eliminated each other because we have a positive and the negative version. So those just go away, and the only thing left is 2. Okay, on the right side, we have 1 still, so the 1 isn't going anywhere, but 9x minus 8x is only 1x, right? If I have 9 and I take away 8, there's 1 left over. Okay, so we could write 1x, right? But people usually don't write 1x. The main way you're going to usually see it is just x. Okay, so now to solve this problem with the second step of this two-step equation, well, I want to get the x by itself. So think, what is the one thing that's bothering us so that we don't have x by itself? is this positive 1. So if I want to get rid of the positive 1, I'm going to subtract 1 from both sides. And 2 minus 1 makes 1. And so that gives us our answer of x equals 1. So notice this first step can really support you so that you don't feel completely lost. Write that down, okay? These 3 points are in a straight line. So we got ML plus LK equals the whole thing, right? After that, you go drop in all of your little expressions, right? ML is 2, and just go plug in everything in and solve them. We'll definitely need more practice there. So let's try number 6. Okay, I would highly recommend that you try this on your own. And we'll go through and solve this problem too. So we got FG plus GH equals FH. Okay, and FG is equal to 4. So we can substitute in that because FG is equal to 4. But now it says that GH is equal to 2x plus 26. So we'll put that right there. And then here for FH, we will put x plus 21. Okay? So the next thing that's going to happen is that we have to figure out which we want to take. Do we want to take x from both sides or 2x from both sides, right? So I usually recommend that you subtract the smaller value of x. That way we don't end up with a negative value. So I took x from the right side and x minus x from the left side. So on the right, what we have now is just 21, all right, because those two, the x and the positive x, right, these two things eliminate each other. And now when we get 2x, right, minus x, that just makes 1x, okay? Now we can't combine these other two letters. Numbers. I can combine the 4 with the 26, okay? And 4 plus 26 is 30. Okay, so we'll do those two things in one step. Now to solve this thing for the second one, we'll subtract 30 from both sides of the equation. Okay, again, we want to get the x by itself. So I don't want to take the 21, I want to take the 30 away. That leaves me with x on the left side, but on the right side we do have to calculate 21 minus 30, and that's negative 9. So your answer is x equals negative 9, and that's what you should have for number 6. So let's take a look at what happens after that. I believe that this is all the 3-point version of the line segment addition postulate. So to get these ones, what happens is you just need to do a little bit more attention to detail and try to figure it out. So we'll talk about the steps I gave you guys on these ones. All right. We had read, okay, label, think. Okay, the fourth step will be check, okay? But we don't want to talk about that until we're done with all our work. So let's talk about reading. Okay, the first thing that it tells us to do is to read this, to find SU, all right? I know it's only 6 letters right there, but you should read them, okay? And then we should go darken what it wants us to find. It wants us to find from S to U, okay? It wants us to find this whole line segment, okay? So to find that length, we have a missing piece, right? If I know how much this thing is of ST, well, then I could add that up with TU, and then I would have the entire thing of SU. So how could I do that? Well, there's a couple ways. I'm hoping that a lot of you guys can look at this picture right here and say, well, wait a minute. If this whole thing is 14, then from here it has to be 6, right? From here to here it has to be 6, because 6 plus 8 equals 14, right? So these two numbers have to add up to 14, okay? Well, because this is 6 now, what is SU equal to? Well, SU is equal to ST plus TU, okay? And what's ST? ST is equal to 6. What's TU? 3. Okay. What's 6 plus 3? 9. Okay, so then that's the answer. That SU is equal to 9. So we could write it separately if we wanted, because that's the big idea. Okay, SU is 9. So after we do that, we can go check, right? We could think about this to see if this makes any sense, right? And so the only way to really check this problem is to double check that 8 plus 6 really does make 14, okay, because that's the only missing number. And so if you could verify that 8 plus 6 actually is 14, you should be able to notice that you did this correctly. So what's going to happen now is we'll move on to the next question, okay? But again, always double check your work and think about that at the end of a problem. Okay, so attempt this problem, please. Think about what that middle piece would be, and then again, don't forget to read the problem so that you're not answering some other question that they're not asking. Okay, make sure we're answering this question, right? Find HJ. Well, let's go darken H and then darken all the way to J. All right, that's what we want to find, that whole length. But I can tell that this has to be a number that we can tell really quickly because from here to here is already 12, right? And the whole thing has to be 23. So that means that right here we must have 11, right? Because 11 plus 12 is equal to 23, okay? So that's, again, 23 is from there to there. So this little missing piece at the end is still 3. So again, if I want to find HJ, well, I know HJ is equal to HI plus IJ, okay? But HI is equal to 11, and IJ is equal to 3, and so this is equal to 14, okay? And again, the only way that you can really double check your work here is by going to make sure that when you do this operation, you actually get that number, okay? And you could actually double check that when I add those up, do I really get what I thought I did? So the best checking here in this case is just making sure that you did not add up your numbers incorrectly. Okay, so number 9, this would be a good one for you to try. I got a lot of questions about this one just because I really want to believe that you guys could have done this on your own, but all the lines made you feel a little bit confused and maybe intimidated, right? So from here to here, we know, right, from this point to this point right here is 12, okay? And then if you can observe, this thing is telling me the whole line is 19, okay? So from there, from J to G, it's 19. So what must this little piece right here, I'm going to go highlight this in, let's say, blue is fine, okay? From here to here, that distance must be 12 or 19 minus 12, right? This must be 7 because 7 plus 12 makes 19. So that's the only possible value we could get for HG. So again, we want IH. So if we read the problem, we want to be careful that we just don't write 7 because that would be incorrect. That's why I'm telling you guys, read the problem before you start thinking because you want to avoid doing a bunch of thoughts that were working in the wrong direction, okay? So now we have at least a piece of it, right? We have one little line segment, but we definitely don't have a number here, and that's what we want. And we don't have a number over here either. So we want to try to get one of those numbers. All right, the trick is to use the last thing that we haven't used yet, is this 13, right? So it's telling me that from G all the way over here to point I is 13. But again, the whole thing is 19. So what does this piece have to be? This must be 6, right? Because that's telling me that from here to here, I have to have 6. Otherwise, they're not going to add up to 19, right? Because 6 plus 13 is 19. So think about it. This piece is 6 from here to here. And this piece is 7 from here to here. So what's the leftover red region have to be? Right? Well, I know that 6 plus this plus that has to make 19. So if we wanted to, we could use our triple line segment addition theorem, and we could do it like that so that we have something to look at. Okay, but I'm pretty sure some of you guys could do this without having to bring a whole equation into it. Okay, the whole thing is equal to 19. If we go drop the numbers where they go, the JI is 6, the IH as well, that's like our X right now, we want to find it. Okay, so put an X for it. And HG is 7, and they all equal 19. Well, I can't combine these numbers with the letter X, but I can add the numbers together. So 6 plus 7 is 13, and this is all equal to 19. So again, to solve this problem, right, I want to know what number do I add 13 to, and then I get 19. All right, well, take 13 from both sides, and that's the operation that'll show us what we need. All right, 19 minus 13 is 6. So we can see that we must have 6 right here for X, and because that is represented by IH, and because that's what it wants, I can write a 6 right there, okay? Because we're thinking about what we're supposed to do. So don't just write the first number that pops up in your brain. Make sure that you're answering the question that they're actually asking you. Okay, so be resourceful on these problems. I'm trying to show you guys one way to do them, but there might be more than one way. Okay, so try number 10 on your own. Pause the video. Please pause the video right now and try this one. All right, let's see if you got the right answer. The answer is 7 for RS. Okay, so this region in the middle will be 7. And you can see 4 plus 7 plus 4 makes 15 like we need. Okay, for 11 right now, you would want to find GH. So try to find what that thing is in the middle. Okay, mess with this problem. Try to find the missing pieces. All right, what does FG have to be? What's this one got to be? Darken the lines. Use your highlighters, whatever it is. Figure out what GH is. So pause the video right now and try it. Okay, we have the answer that you should have got. Zoom out a little bit. The answer is 12 that you should have. Now for number 12, take a look at this one. You have to find ML. So make sure you're reading the problem before you jump in. And I'll project the answer after you do your work. You should have got 7 for ML. Okay. So we're going to call this video right now. This is going to be the line segment addition postulate video. I hope this introduced you to the idea of how we're talking about lines and line segments. One last thing that I want to mention in this video is the difference between these two notations. All right? If I write AB with a line on top of it, the way that we read this is the line segment AB. Okay, that's the way that we read this part. But if there is no line on top of it, then in that case, we're talking about the length of the line. So AB with no line on top means the length of line segment AB. Okay? So there's an important difference between these two, right? Because this is a number, right? And this represents an object's name. Okay? So very different, right? We don't want to consider them the same way. So just understand the subtle difference there, right? All right, I wish you guys luck studying and good luck raising your quarter grades.